Today, a single entity controls roughly 38% of all online shopping in the United States. Its servers power vast segments of the internet, and its rockets are actively deploying a constellation of broadband satellites into orbit. Most consumers interact with this company through a highly simplified interface, a search bar and a buy button that results in a cardboard box appearing on their doorstep. The consumer retail site functions as a terminal for a multi-trillion-dollar infrastructure machine. Behind that interface, the company engineers its own artificial intelligence processors and operates a global logistics network that rivals national postal services. To accurately map this operation, we need to examine how its delivery network achieves aggressive shipping speeds, how its digital cloud infrastructure subsidizes those physical logistics, the custom AI technology it deploys, and why its approach to brick-and-mortar grocery stores is undergoing a radical reset. To understand the machinery driving modern commerce and computing, we have to draft the blueprint of this empire, starting from its absolute simplest iteration. In 1994, the operation began in a Washington state garage with a highly specific, easily categorized inventory, an online bookstore. The founder, Jeff Bezos, utilized books as a wedge strategy. The long-term objective was strict catalog expansion, building the so-called everything store. Physical books were easy to source, simple to ship, and identical regardless of the seller, making them the perfect test case for e-commerce logistics. By 2005, the company introduced the Prime membership program. By guaranteeing fast shipping for a flat annual fee, they altered consumer behavior, establishing a baseline of recurring loyalty that guaranteed high transaction volumes. The following year, the company recognized a secondary opportunity. The internal computer systems required to run the massive retail site were highly efficient. In 2006, they began renting that excess computing power over the internet to outside businesses. A decade later, the digital empire sought a physical footprint. In 2017, the company purchased a massive premium grocery chain, proving their intention to command brick-and-mortar retail space alongside their digital dominance. Selling physical goods online established the initial customer base, but the resulting cash flow funded the construction of a global technological and logistical infrastructure. By 2025, the scale of the retail logistics network reached staggering volumes. The company delivered over 8 billion items to Prime members with same-day or next-day shipping. Regionalization uses predictive AI to replace national transit lines with localized, short-distance delivery routes. Upgraded hybrid hubs push this network deep into rural communities, doubling same-day shipping. In urban markets, they test ultra-fast services, delivering household essentials in 30 minutes. They also introduced an add-to-delivery feature, allowing users to append items to a pending order without incurring additional shipping fees. Within 6 months of launch, this feature accounted for 10% of the total volume flowing through their fulfillment network. Every step of this process is dictated by advanced robotics and AI forecasting. The algorithms determine exact inventory placement to minimize distance and aggressively reduce the number of times human hands have to touch a product. This extreme logistical density operates as a high-friction barrier to entry. For standard retailers, replicating this speed, reliability, and sheer geographic coverage is practically impossible. The logistical machine is massive, but it requires capital to operate. That capital is generated by the cloud computing division. Businesses pay to rent computer power, data storage, and software over the internet. This division is a financial juggernaut. In 2024, it generated over $107 billion in revenue and currently maintains roughly 30% of the total global cloud infrastructure market. Total revenue of $717 billion is dominated by retail sales, with a small cloud slice. Filtered for operating profit, the retail slice contracts. The cloud division expands to generate 60% of profit because renting digital space yields massive margins compared to physical warehouse overhead. The low-margin physical delivery network hooks the consumer, but the highly profitable digital cloud business provides the surplus capital required to physically build and maintain it. The cloud division's dominance is currently focused on artificial intelligence.
Training large AI models requires an immense amount of computing power, and buying standard microchips from outside hardware companies has become a severe financial bottleneck. To bypass those external hardware costs, the company designs its own custom silicon. They developed the Trainium chip specifically for teaching massive foundation models, achieving the same processing workloads at roughly 40% less cost than comparable external options. Once the AI is trained, it relies on a companion chip named Inferentia. This hardware is optimized for the inference stage, executing the actual tasks and answering user queries. They also deploy a general-purpose processor called Graviton, which handles standard cloud workloads while consuming up to 60% less energy. With the physical hardware controlled in-house, they developed the software to run on top of it, a proprietary family of foundation models branded as Nova. The Nova family is tiered for efficiency. Micro and Light handle basic, high-speed tasks. Pro is engineered for deep reasoning. Canvas generates highly customized images, and Real produces high-quality video content directly from text prompts. Moving beyond simple prompts, they introduced advanced AI agents. Systems like Kiro operate autonomously, receiving a complex objective and independently executing tasks like writing code or troubleshooting software bugs. By controlling the entire stack, from the architecture of the physical silicon to the data centers that house them, up to the foundation models themselves, the company secures a cost advantage over competitors relying on third-party hardware. Despite this digital dominance, physical retail proved far more difficult to conquer. The initial strategy centered on futuristic fresh and go convenience stores, relying on cameras and sensors to completely eliminate the checkout process and cashiers. The experiment yielded a clear operational lesson. Frictionless payment technology does not compensate for a lack of distinct brand identity. Realizing the economics failed to scale, the company closed dozens of these experimental locations. Instead of forcing a retail concept that lacked differentiation, capital was aggressively redirected toward expanding the premium natural grocery chain they acquired back in 2017. The revised strategy includes launching over 100 new Whole Foods locations. This rollout features a new, smaller daily shop format designed for high-density urban environments, targeting quick, daily commuter purchases. The innovation lies behind the retail floor. The company is outfitting the back rooms of these grocery stores with automated micro-fulfillment centers. This creates a hybrid logistics hub. Robotic systems pick and pack non-perishable canned goods, while human employees select fresh produce from the store floor. The orders are consolidated and dispatched for immediate, same-day delivery. The shift from automated convenience stores to augmented premium supermarkets proves that physical retail relies on established brand equity. Technology acts as a force multiplier for logistics, but it cannot invent consumer trust. Backed by immense capital reserves, the company continues to aggressively expand its infrastructure. Their most ambitious new project is taking place entirely off the planet. Under Project Leo, they're deploying a network of low Earth orbit satellites designed to beam high-speed broadband internet down to any location on Earth. The satellite network directly expands the company's total addressable market. By providing high-speed access to previously offline populations, they systematically funnel more users into their cloud computing ecosystem and retail storefronts. Every component serves a distinct function in a self-reinforcing loop. Online loyalty feeds transaction volume. That volume necessitates massive delivery networks. The high-margin cloud division funds those physical warehouses, while proprietary AI chips drive down processing costs, and grocery stores double as hyper-local distribution nodes. Data and cash continuously cycle through this closed-loop architecture. An efficiency gain in logistics lowers costs, expanding the user base, which in turn fuels further investment in server infrastructure and custom silicon. What began as a retail website has evolved past its initial parameters. It operates as the foundational infrastructure, processing the digital and physical logistics of the modern world.